Good evening, everyone. Good afternoon, or as it is, good morning for Glenn. So we welcome you and we hope you're doing well and are staying safe. On behalf of AIOUG, this is Ash, and I would like to welcome you today to our next session in the ongoing series of webinars on maximum availability architecture. As you know, we at AIOUG, we aim to provide a platform for technical professionals to network, share, grow, and interact. We try our best to give all Oracle users an opportunity to learn, discuss, and provide a platform to keep in step with the latest trends and enhancements in the database world. We usually have in place in-person events every month, and we've got chapters that are spread across the country. We've got 10 chapters, but in an effort to keep alive the tradition, we've been conducting weekly webinars regularly over the past year and a half. So as you can see, these are the speakers that we have as a part of the MA Online Summit. And I hope you're taking this opportunity to upskill yourself and learn everything there is about MA. Also, I would like to take a moment to thank all our speakers from the bottom of my heart for sparing their valuable time and coming over here to not only conduct the sessions, but also joining in to, answer the questions. As you know, we've had at times around, we've bombarded our speakers with questions, and they've been more than, glad and willing to answer us patiently. So we've got Suraj again today here to help out Glenn with the questions. So I encourage you all to absorb what Glenn is saying, and if you've got any questions, this would be the best way, the best forum you can raise them in. Again, just a few housekeeping rules. The questions that I was talking about, kindly use the Q&A panel at the bottom of your screen for all your questions. That helps us to track them, and soon we'll try and get them out. I mean, we've had requests, so we'll try and get them out on the portal or to the community as well, share the questions. If you need any support, feel free to reach out to us over the chat box. We are around to help you. Another thing we'd like to encourage is create some noise on Twitter. I mean, create some noise that would be the platform where you can thank our speakers, thank the various volunteers who are associated with this, and more importantly, continue the conversation. If a couple of days later you think of something, that would be the platform in which you can reach out to the speakers and raise your questions. Regarding the presentation material, it will be accessible from the AIOUG website, and we would love to hear from you. Your feedback, what would be the next set of sessions you are looking out for? We are looking out for ideas, and we would love to hear from you. You can contact us over Telegram or just shoot a short email to webinar@aioug.org. Send us what you think should be our next topics. We are more than happy to try and arrange and those sessions for you. And especially if you would want to speak, if you want to speak or present on a topic, we would like to hear from you as well. So do reach out to us. So with that, I'll move to the topic for the day. So we have Glenn Hawkins with us, who's a Senior Director of Product Management at Oracle. Glenn leads and manages the Oracle Maximum Availability Architecture Solutions and Best Practices, as well as the team that is responsible for product management and strategy for all the MA products like the Active Data Guard, Flashback, Data Guard itself, FPP, or the online operations, the edition-based redefinitions. So we're really lucky to have Glenn with us, and really excited to hear him talk about MA. So with that, I would like to hand over the session to Glenn. Glenn, could you kindly share your screen?
Yes, thank you. Go ahead.
I can see your screen.
There we go. All right, welcome everyone. Thank you for joining me on your evening. I really appreciate it. As I said before, we're covering maximum availability architecture. focusing on it, not just our standard on-premises, right, which is kind of the core of it, but also how it's represented in cloud, as well as hybrid cloud, multi-cloud, different type of environments. And I'm going to give some examples here at the end of some different types of deployments that can be taken advantage of in those very kind of modern day architectures. And Suraj is with me, so please hit us with Q&A. We love questions. Just keep them coming. Just type them into Q&A, and Suraj gets them, and I'll pick out a few probably at the end. We'll go through them as well for everybody. I'm going to start about why kind of availability is important. A lot of people kind of realize this, but sometimes you don't realize the overall repercussions until it's too late to a certain extent. We'll jump through the different blueprints, and MAE is a set of blueprints at the end of the day. I'll explain that, and we'll talk about resource because maximum availability architecture. Part of what I'm doing here is bringing you up to speed on it. The other piece is to show you where all the resources, all the best practices, all these type of things can be found at your fingertips, and we're constantly evolving them. And then of course the Q&A, which will also happen throughout and tests. So let's go ahead and start with why availability is important. And at the end of the day, it comes out to cost and the impact to your business. And we're specifically talking about, a lot of these examples are talking about unexpected outages. But the fact is that maintenance, upgrades, patching, it happens even more frequently. And there is a cost associated with it. Maybe not quite as high as the numbers that you're seeing here, right? We're looking at $350,000 US on average cost of downtime per hour when a site just goes down. Basically the business just ceases. And then, never mind maybe potential data loss, having to go ahead and recover that as well. And in those, the number of hours, sometimes there's minutes, but a lot of times it's hours, right? Particularly if you're unprepared for it. And you haven't been testing it, and you haven't gone ahead and you don't have a rigorous environment, and you haven't thought through your solution. It can be very, very impactful, very expensive, and it happens frequently. So, 91% of companies have experienced something unplanned outage in the last 24 months. That may have been an hour. It may have been multiple hours, may have been a day, depending on what it was. Sometimes it's just downtime, sometimes combined with data loss, which can be even scarier in some cases, particularly for financial institutions and other companies that can't afford to lose any data. So we talk about some key terminology that's really important to understand. Is first of all, high availability, disaster recovery, and they're different from the perspective of Oracle. High availability is we focus on redundant components, additional service, clustering, to go ahead and provide uninterrupted service. So if anything happens within there or from a scalability problem, we can spin up another node to go ahead and provide that and ensure it's highly available and it's scalable from that perspective, usually within a single data center. Disaster recovery is you can think of it as a site outage. How do I deal with a potentially unrecoverable situation for my entire site, my entire data center? A power outage occurs, some other type of natural disaster, or something else basically causes my entire environment to go down. How can I quickly go ahead and recover that with the least amount of impact to my business? And then rolling updates and patches. This is the idea, the concept here is to be able to go ahead and roll through, let's say, a cluster, or from your primary to your standby environment, to go ahead and minimize downtime when you're doing upgrades, patches, and any other type of maintenance activities, not just for the database, but for the entire stack. And then as far as going ahead and measuring downtime and data loss, we talk about two different things. We talk about recovery point objective, or RPO, and that's the data loss. If the environment is unrecoverable, how much data loss does that mean, right? Kind of going backwards in time from the event. When was the last time I did a backup? If I'm only using RMAN, for example, that would be my recovery point. So you have an objective that you're going ahead, usually goals, and a lot of people are not quite there where they want to be. Recovery time objective is your downtime. So that's a measurement of your downtime since the event until the business is back up and running again. Now, I'm constantly talking about how environments can be more rigorous. And when we talk about maximum availability architecture, it's key to understand what we're talking about. And I want to emphasize that it's not just a set of products. We're not just talking about Active Data Guard and RAC, combine it together, and that's MAA. That's not MAA. MAA is the technologies integrated together into the Oracle database and properly configured with the application, but also all the operational and configuration best practices of the environment in general. These technologies need to be used in the correct way. In addition to that, we have a dedicated team of people that focus on chaos engineering. So they're actually quite literally going ahead and breaking things proactively to give you peace of mind. So as the title says, and the idea is, we're constantly going ahead and literally pulling plugs out of walls, breaking network connections, making things unrecoverable, deleting a bunch of rows from the database to make sure that all our recovery works together, it's all integrated together, and we can go ahead and recover from a variety of different types of disasters or outages, or a combination of outages. Imagine downtime, unexpected outage during an upgrade. These are the type of things you need to go ahead and think about. And this is what the team thinks about. And it uses a technique called chaos engineering, which is out there for everybody. You guys can use it in your environment as well. You can go ahead and kind of look up this concept and this technique. And we're focused on the Oracle database and the applications that connect to it, but you can apply these same best practices to your entire environment to go ahead and build up the resiliency. So keep that in mind. It's a focus not only for MAA, but we also apply the same thing to testing the database in general in our cloud environments and everything like that across all the different systems that we work with. All right, so let's talk about the context of MAA specifically. So we start talking about maximum availability architecture. Once again, we're not talking about something on the price list here at Oracle. We're talking about our solutions, our best practices, and how to go ahead and achieve the RTO and RPO that's most meaningful to your application. What's your goal for your application? It probably changes from application to application. You probably don't have one set for everything. So MAA came from basically 30 years, we're up to almost 30 years now, of customer insight and expert recommendations that we've been incorporating. It all started with our support team, kind of built out from there. And these best practices were built out of that. Eventually, we have a dedicated team. So we have 40 plus individuals that are going ahead and applying, writing up all these best practices, building these up into what you see today, using all those chaos engineering techniques to define 4 different reference architectures that map to different RTO and RPO goals. So it's not one size fits all. You need to go ahead and decide what's right for your application. And it's not usually 0 downtime, 0 RPO for everything, because you have more moving components to go ahead and achieve those type of goals. So we'll take a look at that here in a moment. But on the right-hand side, we can see kind of the categories that we focus on here at MA. And some of it has expanded. We had actually 3 categories. Now we've had 4 that we introduced in the last 3 years. We introduced continuous availability, kind of tying up to our app tier. It's not just a database, it's all the connectivity to the applications and how we can go ahead and support those applications so they're not having to be restarted and they're not impacted, and developers don't have to deal with outages. So continuous availability, data protection, got to protect that data. We don't want the data loss. Active replication, and scale out. And we can see some of our favorite products like Active Data Guard, RMAN, App Continuity, RAC. These are all in here, and they're in different categories. And a lot of these technologies span multiple categories, which makes sense because they're all integrated together. They're all part of one solution here as part of the Oracle database. A lot of them are built into the database. So it's all the features, it's the configuration, the operational best practices, and the team that are constantly testing these that make maximum availability architecture such a trusted resource. And then as far as deployment choices, we have generic systems or engineered systems like Exadata. And as we get up to cloud, DBCS, XSCS, Exadata, cloud to customer, all the way up to autonomous database, right, which can be run in our cloud, in our public cloud, or on a customer as well. So you have those different options, which is different than we just talked about last time around, as that's a new offering to have autonomous database at customer as well. So as we look at these different tiers, they fit into different categories. You know, it's not necessarily maps up to this, but a lot of times bronze is used for dev test, less critical prod, maybe an internal application. It's composed of a single instance, restartable. RMAN's at the core from an RPO perspective as far as the data loss. And then as we go ahead and have high availability to that, we start looking at, you know, basically providing kind of rack and making it highly available. Clustering is built into it. And once again, you see that bronze plus there. This is an important aspect of these reference architectures. They build on one another. And this is a key to the concept, because a lot of times you may start with bronze, and then as the application and more users start to go ahead and utilize it, you may go to silver, gold, platinum as we go along. A lot of our customers are gold. Gold is really where disaster recovery takes place. That's where we introduce disaster recovery into the picture. It's our most popular MAA tier for people running production applications that are servicing external customers. And then we have platinum for those that need zero downtime, zero RPO for both planned maintenance activities as well as outages. That's where kind of platinum fits in. And they all, once again, build on each other. The idea is that you can keep on going ahead and adding more. You can create a silver environment and go ahead and add gold. We can go ahead and convert gold into a platinum environment, right? And then a lot of different technologies in there. I'm going to talk about fast start failover, multiple standbys, and some of these best practices that are important on this front. So let's take a look at the different tiers. And you know, probably every time you guys see us present, some of these have changed. And, you know, it's a mixture of, you know, you have to look at kind of the footnotes in there. A lot of it ties in. The footnotes usually represent different best practices that apply to it, where some of these numbers have changed over time. But bronze has stayed pretty consistent. And it's really a single instance using clusterware restart. So you have Oracle restart there, using ASM associated with it. RMAN's at the core, as I mentioned, from an RPO perspective. But we do have the option of ZDLRA, which is our recovery appliance. Which basically uses data guard, or uses active data guard, should I say, on the back end. That's included with the solution. You don't even know it's there. It's part of the ZDLRA, the operations of it, and it can provide zero RPO for basically all the tiers. So that's an optional piece. We have a lot of optional pieces. Exadata can obviously be built into it, but usually that's kind of at the silver tier because you have rack in the picture by default with Exadata. But multi-tenant is also there. Multi-tenant is really important. You know, particularly you'll hear a lot of presentations. You'll hear Larry and Juan and Andy talking about converged database and our strategy there, and the fact that we've got all these different data types and workload. I did a presentation just yesterday on that, a session, which you guys can go ahead and look up, the converged database, where I talk about that. But all those different workloads and everything are all protected by all this high availability, all this disaster recovery capabilities in here that we have. And multi-tenant allows us to go ahead and take advantage of that and still keep all the portability, all that isolation built into it between the different tiers while still being able to take advantage of that converged database strategy, right? So you have your spatial data, JSON data, and all those different things that you can go ahead and put in the Oracle database. So bronze is kind of key to that, and multi-tenant is one of our core pieces, especially as you move up to 19C. We almost always recommend that you consider it. Now here's why, right? So multi-tenancy is going to go ahead and give you a bunch of different capabilities that even expand beyond MAA, right? You have your applications that can run. It gives you that isolation that I was talking about. So you don't have a monolithic database on there. We're not going back to the monolithic database days. We have all the capabilities here. And if you're using it, you have a bunch of different ways. Obviously, we have PDBs that are running on top of there that keep that isolation, those portable databases. You can have them running spatial data, all the different types of data types, different workloads, different applications, all running on a container that you can go ahead and take advantage of. You configure data guard or active data guard just one time against the entire container to go ahead and fill over, which goes ahead and really is that manage many as one advantage that you have. Same thing for backups, lots of different advantages there, but you still have the granular control that you need to go ahead and control the different PDBs. So you're basically going to get your cake and eat it too with multi-tenant capabilities of the Oracle database. Now, A few other things, it's also well known for consolidation, but the rapid cloning and the provisioning pieces to be able to set up test environments, snap clones, refreshable PDBs, which are essentially going ahead and doing redo replication across those different clones. You can go ahead and set those up. We take advantage of a lot of these technologies and a lot of the SaaS applications that we have as well. The manage many is one, right? I mentioned data guard, but there's a lot of different controls and so forth you can do at the container level, or you can do it at the PDBs. Historically, you would have had to go out to each one of those databases and go ahead and do any type of configuration change. Now you have the ability to do it a single time, have it apply to all the PDBs on there. Upgrades are extremely easy as part of it as well with the Rapid. You can always move a PDB from one container to another and upgrade it along the way, which is a huge advantage that you can take advantage of, particularly if you combine it with the refreshable PDBs. You can do that and minimize downtime. So just one of the features that you can take advantage of just in our bronze tier or any tier above it. And then you have a lot of capabilities, a lot of enhancements, security that you have, the integration with basically all our other from rack to data guard, not to data guard, are all there as well as part of multi-tenant. So as you move to 19C in particular, if you haven't already, we recommend, Oracle recommends that you consider going to multi-tenant. Beyond 19C, it's there by default. It will always be there. Whether you know it or not, you will have at least one PDB there that'll be running in the container. So everybody will be able to take advantage of it. But you only need the multi-tenant feature. You only need to license the option if you go beyond 3 PDBs. So otherwise, you can go ahead and just take advantage of it. So with Bronze, RMAN's at the key, right? We've introduced a lot of integration with the cloud as well. One of the more popular hybrid configurations I'll talk about a little bit later is to do backups to the cloud, free up your storage, kind of push it in there. And we recommend always having a remote backup that gives you the capability to do it. And RMAN has that ability to go ahead and define that. I won't go into a lot of detail on it, as I expect, but everybody in our audience here has gone ahead and used RMAN or is familiar with it to go ahead and create backups. It's also a great way to move to the cloud. You can go ahead and push your backup to the cloud, and then you can go ahead and convert it into perhaps a hybrid environment or a standby environment, and then you can even set up hybrid DR from your on-premises to cloud. So, lots of uses there. Now, Recovery Appliance, I'm going to talk about a couple things. Let me just go ahead and kind of expand things here. Make it easy. I want to expand it all the way out. So as I mentioned, our recovery appliance, our ZDLRA, goes ahead and utilizes active data guard under the covers. So it goes ahead, it keeps transaction blocks. You take one backup, and then it's incremental forever from that point. And you can do a virtual full backup to any point in time, right? So huge advantages beyond what we have with RMAN when you go ahead and introduce our recovery appliance. And then, of course, you can push that to another remote replica. So if you have another ZDLRA system in another data center that you can go ahead and push to, or to our cloud storage, or to tape, or whatever you want. I also like to use this slide to introduce EM, right, which isn't directly part of our MAA, but it's the key to going ahead and configuring and holistic monitoring. And it has compliance built into it. So Enterprise Manager, Cloud Control in particular, is what we're talking about here, that can monitor your entire stack, multiple databases. It makes life a lot easier from a configuration standpoint, monitoring standpoint, diagnostics and tuning. Many of you are already licensed for it. Most people have our diagnostics and tuning. So taking advantage of a lot of those capabilities is very worthwhile. And it makes things a lot easier from an MAA standpoint, as you have kind of compliance and configuration management built in. So we usually recommend it. And certainly if you're using Exadata or using our recovery appliance, it's almost mandatory to go ahead and really monitor the hardware as well as the software running in the stack. And by the way, if you're using our Platinum support team, our Platinum support team is assisting you on your configuration. They use this gateway. They're using Enterprise Manager as well to go ahead and monitor and manage all these systems, including the recovery appliance. I'm going to talk about a couple of technologies here that I feel like we jump over all the time, but they're key. They're available to you, and most of our customers are taking advantage of them, but we almost take them for granted, And we have other people in the market that bring them up and as new features. Oracle's had them for over a decade. And one of them is online operations, or we like to call it DBMS redefinition. It's a package within Oracle. And essentially, you need to set the storage aside, but it allows you to go ahead and make changes to your tables. You can reorder columns, physical structures, transform your data without taking any downtime. You keep everything online. And we even have, it's very fault tolerant to go ahead and again set it up. And we do our best not to go ahead and get any exclusive locks on it while we're going ahead and doing. Essentially, it's copying the data. So as I mentioned, you have to have the storage associated with it. Everything's tracked in the $$ online redef, so you can go ahead and look at it. Once again, if you're using Enterprise Manager, you can look the monitoring there, or you could just go ahead and spin up SQL Plus, and you can directly go ahead and query the $$ online redef. But online operations is key to being able to make simple changes to your application, or, well, I should say the database and tables. So I'm going to talk about how you can make updates to your application without taking any downtime in a little bit here. So this supplements that with any changes that you want to make, simple changes that we made to the database. And we've gone ahead and added a lot of features and gone ahead and enhanced it to go ahead and take advantage of multi-tenant and all those capabilities well over time. The other one is Flashback, right? And Flashback, it's a rewind button at the end of the day. And I like this example. You know, I think most people look at it, they laugh and go, wow, look at that. Somebody gave everybody a promotion, right? Accidentally in the database. Well, imagine if the promotion was tied to higher security, right? And now all of a sudden, all these people had access to things that they shouldn't. This could actually go ahead and be a potential policy infringement, right? And could introduce fines and all kinds of things if it wasn't dealt with very quickly, because people shouldn't have access to things that they shouldn't. At the same time, you know, if you look at a lot of systems, it means, well, okay, somebody just went ahead and did this upgrade. I can try to manually fix it, or I can go ahead and recover from backup, right? And take the hit associated with that. Or if you're in the Oracle database, I could go ahead. Of course, I could hit the rewind button for the entire database, but I also have the option to go ahead and just do a flashback at the table level, or just at the transaction level. Now, this is fantastic. This means we have, and what it means in Oracle, essentially we have physical flashback for the entire database, and you can have restoration points and guaranteed restoration points that you have. Guaranteed restoration points, we keep them around forever. And restoration points depends on how much storage you have available, or they can time out. But those are for rewinding the entire database, but you can also do it at the table level, logical flashback, at the transaction level as well. And this means that you don't have to go ahead and back up. You can preserve most of your data and just do a quick flashback of the table or tables, right, at a time. So you have that type of granular control with this technology. And it's very unique in Oracle. So it's good to know it's at your fingertips. And some people are not familiar with it. Maybe they're familiar with the flashback as a rewind for the entire database, but the table is really powerful, or at a transaction level. I'll talk about Silver. So, you know, I've converted my little rack into an Exadata here to show that, you know, this is really where, if you're on Exadata, you by default will start with rack. And that's where our clustering comes in. A lot of you are familiar with rack. It's evolved significantly over time. It's one of our main focuses. We use it on basically throughout our cloud. We use it on all our applications. And if we look at our outage matrix here, now we're no longer dealing with our last backup, right, associated with our RPO, right? So if we go ahead and look at this from an RTO standpoint, we have, we still actually do have RMAN, I'm sorry for the RPO, but for the recovery time, we're going ahead and using rack to ensure that we have single-digit seconds we can recover a node. So if server goes out in the cluster, we can easily jump over to another server, right, another node in the cluster. From a planned maintenance standpoint, you notice that also was dropped to 0, and that's basically our rolling patching. So you can go and take advantage of our rolling patching as well. But the real missing link here, the real advantage, is the app continuity feature, which is protecting your in-flight transactions as well. And the reason I say it's new is because a lot of people are not aware of it. A lot of people are aware of rack and how it protects their committed transactions, and we're going ahead and minimizing downtime. But app continuity is kind of the magic sauce to make sure it doesn't impact the applications above it. You don't want an outage to occur and the rack cluster, everything's up and running, transactions start playing on the other servers, but you know, maybe your app server that was impacted might need a restart, or those transactions fail, and now your app developers have to deal with that situation. Or worse, the transactions fail and it goes up to the end users, and now they're impacted. The people are actually using your application. None of that is ideal. So as we go ahead and look at this, let me talk just a second about rack, because most of you are familiar with it. But that's from as I mentioned, from a clustering standpoint, and you can do the rolling upgrades that I was going ahead and talking about. It's very simple. One of the nodes goes out, we just roll over to one of the other nodes. So zero downtime, especially for patching, very popular for any type of security patches or anything like that you're going ahead and doing that you can time with the database here. So most people are going and taking advantage of it. Everything else is going to go ahead and build on top of that once we start talking about gold and platinum. So you always have 2 or more nodes, right? Usually people have 2 or 3, and you can go ahead and scale up and scale down as needed to add capacity. Now, let me jump back to what I was talking about with the app continuity and how that ties into it. So app continuity is not really new. We started to introduce it kind of in the 12.2. It built on top of Transaction Guard, but there's some very, very fundamental differences. And I shouldn't even say it really built on top of it, because it's fundamentally different. With Transaction Guard within your application, you had to build to certain APIs within our database to go ahead and ensure that transactions, if it failed, if one of the node instances fail, and it falls over to the other node, in addition to committed transactions, the in-flight transactions were replayed on another node. The idea there is to go ahead and ensure that the application client is not impacted, which can have a lot of repercussions if it is. I've seen people have to go ahead and start rebooting application nodes and stuff like that, right? Their mid-tier starts to get impacted. Transactions fail. Your developers, as I mentioned, are having to code for all this type of error handling that they would prefer not to, probably, and can be very error prone, but they no longer need to. As we go ahead and we start to introduce this type of capability with Transaction Guard, but it required application changes. Application continuity does not. It's just your connection URL, and you're using the correct database JDBC drivers or whatever the database drivers are for the particular technology, whether that be .NET, Java, Python, PHP, Node.js, whatever that is. You go ahead and use the correct drivers, use the correct connection URL, and the Oracle database will take care of replaying those transactions, ensuring they're only replayed one time. It will go ahead and rebuild the session state, replay the transactions, and from the application client perspective, the mid-tier, your end users, is just a brownout at the end of the day. And you do have capabilities to set different properties to go ahead and decide what type of timeouts you may have associated with that, if you can have it. And this is very useful in planned activities as well. We'll automatically go ahead and drain sessions out. Very useful with OLTP. With batch processing, usually batch processes are running for such a long time that you may want to go ahead and turn them off, because they'll probably go beyond the timeout that you have. So when you go ahead and drain the sessions using TAC, you want to set a timeout, because essentially it doesn't take down the node until the transaction, until you hit that timeout, right? And then they're replayed on another node associated with it. But that replay can take a significant amount of time with batch processing. Probably not quite ideal for this. But with OLTP, those transactions will go ahead and be replayed, and the result will go back to the application, and things will continue on as if there was no outage at all. I'll talk about application continuity in the context of Active Data Guard as well, as it's also there. But we're specifically talking about it with RAC in this case. And of course, this technology is just built in. It's not something that you install. It's just there as part of RAC. You get it as part of RAC. It's a feature. Okay, so for a planned maintenance activity, I stole my own thunder, so I'll just expand this piece. This is the way it works, right? Transactions come in. For whatever reason, database service, we're going to go ahead and stop it. Maybe we're doing a rolling patching session. The service goes ahead. It's going to go reply, start on another rack service. Sessions will reconnect. Services are drained. New sessions are starting up on another node instance. And then for those that are replayed, if it went ahead, let's say it went beyond the timeout, beyond the draining timeout, so drained up to a certain one, but let's say there's still a few transactions that are left over there, those are going to be replayed. So those are replayed just like we would handle an outage, And then, of course, that result, that database request will return to the user. All right, and in an unexpected outage, something very similar is going to happen, except it's happening all at once, right? Database request goes out. In this case, we have no timeout. There's no draining associated with it. All the sessions are going to go ahead and replay on another node once it's gone ahead and reconnected. So simple as that. And this is what everybody, I mean, this is what we're asked about all the time is, well, you know, when I'm doing rolling patching, my application has issues. You know what? It's you know, I don't really get a no blackout, right? If you don't want a blackout, you want to use application continuity. That's what's ensuring that you have no blackout when you do these type of patching events or type of maintenance events. So very, very important piece of the app continuity. I'm going to spend a little bit of time here on Gold because Gold is really, as I mentioned, it's our most popular tier for production critical applications. And a lot of people think of it as just rack. Okay, I get rack and I have active data guard. I'm good to go, right? Well, not exactly, right? It depends on what you're trying to achieve, and there is variations in Gold. As you kind of see in the predominantly kind of a maybe oversimplified diagram here, we don't just have one standby here. We have at least 2 standbys, potentially more standbys, and I'll tell you why, right? But this is the default, and if you look at our documentation, so we have a bunch of new documentation on MAA, and if you look up Oracle Data Guard best practices, you'll find all this new documentation, all those technical papers that we created. We went ahead and consolidated them, made them very easy to navigate, and we focused specifically on Data Guard and Active Data Guard as we have so many best practices associated with them. And we explained why we recommend this configuration. The reason is very simple. You want your protection, and we talk about regions. Regions are fairly far apart, right? We're assuming maybe hundreds of miles. You're protected from a regional power outage or anything that may impact that entire region and take it offline. However, regions are 100 miles apart, which introduce latency. And if you, depending on your protection mode of your active data guard, in order to get a 0 RPO, well, I have to set up synchronous replication, which means data guard has to go ahead, that remote standby. If let's say we just had that primary and we had the remote standby, that would mean that remote standby, if it was set up with maximum protection mode, which gives us synchronous replication and 0 data loss, it would have to wait for the acknowledgement from the remote standby. If we use Farsync, we get it instantaneously back to the primary, and we're going to get some kind of performance hit on that. No doubt about it, right? Depends on what the latency is on that, but you would expect some latency because they're so far apart. So usually you want to go ahead and have your primary and your remote standby that's giving you all that protection in that other region. You want to go ahead and set it up asynchronously. You know, maybe our maximum performance mode, right, which goes ahead and sets that up. So it's not waiting for any acknowledgement. It basically fires the redo over to the standby, and then it's committing the transaction instantly. Right? So no performance impact associated with that. However, we in most cases, you know, we're not talking about entire region outage. We're talking about, you know, just maybe that one rack system has a problem. Let's take down the entire cluster for whatever reason. And for that situation, what we want to do is really set up a local standby. And we can set that up in maximum protection mode, right? Or maximum availability mode, get synchronous replication across that. A lot of times it's maximum availability mode. It stays at max protection unless it hits a timeout, and then it jumps into max performance to minimize any type of impact that's happening on the primary. These are all designed so you can go ahead and have the flexibility that you need to go ahead and meet your RTO and RPOs, right? And I've seen all kinds of configurations. Now notice fast start failover. So we have fast start failover, which you get with data guard, just basic data guard. You get fast start failover, and that will go ahead and automate the failover to the local standby, so which is set synchronously. So if our primary goes down and it's just a primary, no problem. We have 0 data loss associated with that. Now, if the entire region, Godzilla attacks, blows out the entire thing, power outage, meteor hits it, for whatever reason, if you fail over to the remote standby, it's equal to the redo transport. And redo transport is your data going over the wire. How long does that take, right? So it opens you up to a tiny bit of potential data loss associated with that. But this is essentially where you can go ahead and take advantage of it. Provides the maximum flexibility. It's usually what we recommend. There are options. We're going to get into Platinum here in a moment. But usually that's what I recommend. We have local backups on both sides of the fence, so both regions. And usually our remote standby also has another standby associated with it because we want to, you can go ahead and switch over so that if that becomes the primary, you still have a local standby over there. There's other reasons to have additional standbys associated with it. I'll talk about DBMS rolling being one of them, right? That we have ability in active data guard to go ahead and do rolling upgrades as well. But we don't want to impact our disaster recovery or endanger our configuration. So we have an extra standby that we can go ahead and utilize for the upgrade. That's what we usually recommend, taking advantage of that. So Gold, we have all these capabilities in there that we're taking advantage of. And at the core of it is active data guard. So why active data guard and not data guard? Well, first let's go ahead and talk about why data guard, right? And how does data guard differ from anybody using storage remote mirroring? So a lot of people will make a fundamental mistake in their disaster recovery and use storage replication to go ahead and do storage replication. It's fine for the mid-tier, for the app tier, and we usually utilize it as well. But for the database tier, this is critical data, and data loss, unless you're testing it continuously, you want to go ahead and make sure it's being validated all the time at the block level, right, by something that understands the database itself. You don't want this fire and forget storage replication. Storage replication will copy over everything. So somebody accidentally deletes a file on the file system, and guess what? That's also copying over into the storage. It's going to delete it on your standbys. A lot of people don't figure out that they've corrupted their standbys until it's too late. They try to fail over, oh my God, our standbys, the same files are deleted because I was using storage replication. Now I'm going to have to try to go recover from backup. I've just lost half a day's worth of data, impacting my business. Not ideal. It's why we created Data Guard in the first place. Data Guard does everything in memory. So it's doing it in memory. It's just doing it to redo. There's validation that's happening kind of across the board, right? So it goes ahead and builds that up. So block replication that's happening. And it's going ahead and just doing it. We have synchronous and asynchronous replication. We have basically block validation. It's not copying over all the files of the file system. It's all happening in memory. So a lot less data is going over the wire with just a redo. And because it's just a redo, it allows us to do a ton of validation on it to ensure it's not corrupt and ensure it works properly. So Data Guard was built specifically for the purpose of protecting your data. And we definitely don't recommend using any storage replication with the database layer for all the reasons that are mentioned. However, Data Guard's at the core of it. You get Data Guard with Enterprise Edition, so you can go ahead and take advantage of it. Data Guard Broker there is a broker for controlling it, or you can use Enterprise Manager, as I mentioned before, which will integrate with the Data Guard Broker to help you manage your configuration and monitor it to get all the configuration data. Simplifies things quite a bit. But we recommend active Data Guard, right, for an MAA. So why do we do that? I'll tell you, it's one of the main features that Active Data Guard is known for. Is the term active stands for the fact that you can use your standbys and offload a read. It used to be a read-only workload. Now it's a read-mostly workload because we can have a few DML updates and inserts associated with that, and we'll redirect them with that DML redirection feature and make the round trip. So it was very known, Active Data Guard, very known for going ahead and maybe taking your reporting applications and having them go against those standbys. So they're not just sitting there idle. You can use your DR environment for those other applications. That's excellent. That's not the reason, though, that we're going ahead and recommend it for MAA. It's one of the reasons because it's constantly going ahead and testing our standby environment, which is fantastic. The fact that we know that standby is up and running and can service the application is great. And having that read mostly workload against it helps with that. But it's really the automatic block repair that you see there and application continuity that you see those small little clouds over the primary and the DR data center. That really is the reason that we recommend it for MAA. Automatic block repair automatically will go ahead and repair any corrupt block in the primary or any of the standbys. It does this automatically. You just get a little point in your activity log, and it takes care of going ahead and doing this bidirectionally, or I should say multi-directionally, across multiple standbys. That's a huge advantage. You don't, a lot of times you don't get a corrupt block. It's very rare. A lot of times it has to do with a massive kind of hardware problem that you're having. But when it does happen, it is not a happy moment, right? These type of rare type of situations, just like a power outage and any other type of disaster, it can be extremely impactful to the application, the data, and everything else that you have there. Automatic block repair takes care of that. And I've seen customers experience this and they don't realize that automatic block repair wasn't enabled. And they want to go ahead and enable that. And it's enabled the second you go ahead and turn on Active Data Guard, enable it. It will take advantage of this and start going ahead and handling it automatically behind the scenes. And then app continuity, the ability to go replay transactions, once again, is critical to this. Those are the two main reasons why Active Data Guard is part of it. It's a data protection deal. Now, the fact that we also have Farsync and we have DBMS rolling, that rolling upgrade feature that I mentioned, these are all key pieces as well. That you can take backups off the standbys. Very nice. You don't have to take them off your primaries anymore. You just take them off your standbys because they're an exact physical replicant of the primary. So a lot of advantages to that, and this is kind of why Active Data Guard is always recommended for MAA. We do the Farsync capability in there. Now you note that I mentioned multiple standbys in the gold environment. One of the alternatives that you'll find in our documentation is the use of Farsync. Farsync is a small instance, just a control files, just a log files, no data files. You're not going to fail over to the Farsync instance. But what it's designed is you put the Farsync instances, they're very small, lightweight components that can be actually co-located for multiple databases. But you need to have them similar to the local standby. They need to have some level of isolation. With the local standby, we recommended ideally you have a data center nearby, right? Another data center that's within from less than 1 millisecond of latency associated with it. Same thing with the Farsync instance to go ahead and set up. So they're similar from that perspective. You need to limit the distance because it's synchronous for applications of the Farsync instance. And then the Farsync instance's job is to go ahead and do asynchronous replication to one or more standbys that are out there. So it takes all that load off the primary to go ahead and push it to multiple standbys. So that's where your redo is compressed over the WAN. And you can offload your transport compression and your encryption over to the Farsync instance as well, which is another advantage to go and take advantage of. So a lot of different other types of features with Farsync. People use it to create reader farms as well, taking advantage of the Active Data Guard feature. But it's another alternative that we have out there. But once again, I emphasize, one of the things you have to think about, similar to the local standby, is where can I go ahead and put that Farsync instance? I need to have it. I need to have that isolation in there from power outages, from network outages, while still ensuring it's close enough to the primary to do its job, right? So kind of a similar kind of perspective. Very simple component though, and now it can be managed from the broker as well and created from the broker. So we added that recently, the more recent features. I won't talk a lot about this in the interest of time. I'm going to go ahead because I want to get to some of my multi-cloud and some of my examples here, and we still have Platinum to very quickly go through. But application continuity essentially works with Active Data Guard as well. It's part of it. It's one of the reasons it's a key part of MAA. And it will fail over those transactions once again, so you don't have a blackout, you have a brownout from the perspective of the application. It's critical to really if you really don't want those blackouts. DML redirection, I think I already mentioned that we have the ability now with those active standbys to do the occasional insert or update. You ideally want to keep it below 10% of the overall workload. I have a nice blog post on this that you can take a look at for tuning it. And when I say 10%, I'm talking about 10% of the workload on the standby, not the overall primary. You're not going to send all your writes over to the standby because you can see it makes the round trip still. So the workload comes in, you get your occasional insert or update, it redirects it out to the primary and makes the round trip back to standby again. Great for reporting applications to do an occasional update, right? Imagine you're wanting to go ahead and track people that are running reports. You have a reporting database going, or reporting application that's going against the active standby. I want to track who's calling which report. I want to track how many reports are being run. So I need to do an occasional insert or update. I can go ahead and do that with DML redirect. What I don't want to do is assume an full active environment and try to balance my workload between them, as that will kill the performance on your standby. That's where you'll see the performance. I will say with 21C and beyond, we've gone ahead and tuned this even more. So you can actually even update, you can even do more updates and inserts than you could before without impacting the performance. It's actually pretty significant. And we'll be redoing that blog post. I'll have another blog post on the tuning with 21C because we probably go beyond the 10%. And we're still trying to figure out what that recommended percentage is so we can give you guidance. Mira, low latency, this is basically using all your rack nodes. So you can go ahead and optimize, do parallel redo apply. So if redo apply, if you're getting bottlenecked on it, multiple instance redo apply is going to go ahead and allow you to scale that much more evenly. You can see you get a huge boost. I'm not going to go through all of this kind of in the interest of time as I'm already running up against my hour here, but Mira is a key piece as opposed to Sierra, which is our single instance redo apply, which is the default. And that brings us to Platinum. So a lot of people have basically kind of almost, I have a lot of people start with Platinum. They go, I want, you know, Glenn, I want zero RPO and I want zero RTO. And it's fantastic. We can give that to you. But keep in mind that there's more moving pieces, more things to think about. You know, you need to go ahead and look at it. Now, Golden Gate is usually kind of at the core of Platinum. It's usually what we talk about with Golden Gate replication happening right there in the middle. We have two primaries. So this is where the active is. So, you know, we don't have it. It's not active data guard with the DML redirect. If you want active, this is it. Go Golden Gate in there. We'll do Golden Gate replication. But you know, keep in mind that Golden Gate replication is asynchronous in nature. And that means you have to think about conflict resolution. If you have workloads running against those two primaries, and you can even have geographical affinity. We can be sending, if you have your one data center in Europe and one of them in North America, you can go ahead and use global data services, our load balancing, for example, or your favorite load balancer to balance out the load right across those. So we can go ahead and funnel transactions to the appropriate. GDS is also the technology that's a lot of times used to split your workload between read-only or read-mostly and your normal read-write, right, if you're using your active standbys. Lots of ways you can do it, but that's one of them. Notice that we have both standbys. So we have local standbys on both sides. So I'm guessing you could probably guess why we're doing that. Because Golden Gate's asynchronous, but we want the zero data loss still. So we need active data guard still in there. Fantastic. We also want app continuity in there. Golden Gate doesn't support app continuity. Active data guard does. So we still want to go ahead and protect it. We still want all those advantages. So we have local standbys. We have local backups. You can see all the building blocks, the bronze, the silver, the gold, still here, still part of it. And we usually recommend a Golden Gate hub configuration. I'll talk about that in a moment as part of this. This is how you do it. You can do zero upgrades at this point. The advantage is really a lot of times in the kind of the planned maintenance where you can go get here because we can upgrade one side of this and you can do active between these two primaries, or we can do active passive. You could have the load balancer. It could be one load balancer click away from switching over to the other environment. So we could do that too. That's another option available to us. The advantage of having active passive is you don't have to worry about conflict resolution. I like to bring up the most simple one would be sequences. So if we have a sequence and we have them both primaries, we obviously cannot have a single sequence incrementing by one on both of those primaries, or we're going to hit some type of conflict because of the asynchronous replication there, the catch-up that's going to happen. So maybe we want to do odd and even associated with that. That's an easy way of dealing with that one. But there's things to think about with Golden Gate in the picture, and it can become a little bit more complex. So this gives you zero RPO, but at the cost of some complexity. Now, Golden Gate's not the only technology here. We do have some alternatives associated with it. With Golden Gate, we talked about a lot because people like the active. But we also have two other technologies in here. Now, part of the reason these are in Platinum is because they do require application changes to take advantage of them. But they're core solutions, right? And that's our edition-based redefinition, which has a unique position of being the one part of MAA that focuses on the application upgrade, not the database upgrade. How can we get zero downtime with an application upgrade? Well, guess what? We could do hot upgrades, right, with zero downtime, having both the original application up and the new version at the same time with this feature. I'll talk about it briefly here in a moment. And then Oracle Sharding, which is our horizontal partitioning. A lot of times we can mix and match, and some of these technologies could even be used in bronze and so forth. So Golden Gate is using logical replication to do what it does. Basically, everything you see there, all those little arrows would normally fit inside our hub, all the trails. The only thing that sits on the source and target in a modern day Golden Gate architecture, if you're using our microservices as opposed to the classic, is the log miner. Everything else would be in the hub, and the hub would be deployed, the Golden Gate hub would be deployed in high availability as well. Very important, because with Golden Gate's there, we want our high availability feature to also be deployed in a high availability solution. We have a dedicated paper that you can look at. We'll walk you through exactly how to set that up. So logical replication across there, of course, you can go against Oracle and non-Oracle, and you have control over which tables and everything, complete control with the logical replication. Here's how we usually recommended. We have 2 standbys. Notice they're sitting in there. You see all those arrows in the middle? Only one of those arrows would be active at one time. They look green to me. I don't know what color they look like to you guys, but there's only one of those. And the idea is if the primary goes out, one of those data centers will swap. Golden Gate will swap its replication over to the standby. So all those green arrows are your Golden Gate replication. The red arrows are your active data guard replication. So EBR, we're going to do another session as part of one of our other series on EBR. We're going to start talking about, a lot of people are very interested in this. It's how we do, by the way, every zero downtime upgrade feature that you hear about with EBS or anything else within the Oracle stack or on our cloud is using EBR. It's how we do it. So it's basically you have 2 editions of your schema running up again the same, more than just schema, basically all your database objects running within a single database. And you have to start using editioning views instead of physical tables, so you need that one-time switch. It usually is very easy. You change the name of your physical table is the easy way to do it, and you rename the editioning views, which mirror those, to the name of the physical table, so you don't have to change your application. But you're keeping 2 editions up and running. Cross-edition triggers keep those data propagated in both directions to keep them in sync with each other. And so you can run 2 versions of your application that are using the underlying database objects simultaneously. So once again, you can look at the technology with tons of papers. We have a presentation on this, and I'll be doing more conversations on that later. But it would take definitely a good hour to go ahead and talk about all the nuts and bolts of that. And then Oracle sharding, right? Horizontal partitioning, right? So that means all the columns are the same in our tables, but the rows are different depending upon a sharding key. So we've gone ahead and split it out. So we go ahead and split it out. That sharding key, whatever that might be, we go ahead and use it. You can have tons of shards. You can expand your shards associated with it. Each shard is its own database instance, protected with RAC and Active Data Guard, ideally, or Golden Gate. So you can have all the capabilities that we talked about here, but you get that isolation. If one shard goes out, we just lose those rows. We don't lose the entire database. So it's something to kind of think about is the way this works, right? So it can be used with geographical affinity, for example. Very good for keeping data inside a certain region. If you have requirements to keep it inside a certain country, for example, you can create a shard in each one of those countries, break it out per data center. And go ahead and take advantage of it that way, right? And GDS is actually built into this. We use called GSM within sharding. That's how it works its magic under the covers. So the advantages is all the linear scalability. I mean, you can imagine you get a ton of scalability advantages associated with this. Extreme availability, because one of those shards go out, no problem. Everything else is still up and running. And of course, that one shard is hopefully protected with all our MAA tiers, right? Silver and gold. And then we can take advantage of that geographical distribution as well here. All right. So, I will point out that in our cloud, we have some key advantages. And DataGuard really has evolved to what we call autonomous DataGuard, where you can turn it all on with just a single click. And autonomous database shared is 2 clicks, actually, to go in and configure it. Then you configure it, you hit enable autonomous DataGuard. Boom, we go ahead and create a standby for you, set it up on another data center, and you're up and running. And I will tell you, we were doing that just at the availability domain level within the same region before, and now we have cross-regional as well. So good news there. That's something we just advantage. So that's autonomous database shared. We always had that with autonomous database dedicated. So gone ahead and evolved shared to also have the cross-regional capability there. So huge advantage of it. And autonomous obviously is kind of the fruition of a lot of our MAA built in and all automated from the ground up. So now I'm pretty much I'm out of time here. I know it's very late there, but I will quickly point out that we can do this in a hybrid. Hybrids are excellent for DR as well as backups. Push them to the cloud. You take your backup to go ahead and create this. We have a whole paper on this. You have your primary. You go ahead and take advantage of DataGuard, Active DataGuard. You can even use VDM or zero downtime migration to automate this whole step of creating a standby in our cloud. But you create a backup. Normally, you would create a standby or use VDM to do that, and you set it up. It's also how you could go ahead and migrate to our cloud very easily. And then we have the observer that would be set up probably in another region or another availability domain, some level of isolation to get the fast start failover, assuming that you want that. So this is a great way you can get bronze, gold, platinum. You could also do golden gate associated with this. And then, of course, a simple one is you can just push backups to our cloud. And I was talking about that a little bit earlier. And we have our gold matrix there that you can kind of see how that would work. Take advantage of it, right? Lots of different configurations that you can go to do with DBCS, Exadata Cloud, whether that be Cloud at Customer, or it be our public cloud, or XSCS, XSCC, or autonomous. Notice that we're basically automatically at silver when we're in our cloud because you're using Active DataGuard. You've already configured Active DataGuard. So you're going ahead and setting it up at the bronze level or at the gold level. We're jumping right over silver because if you're using RAC, you're automatically jumping to gold because you have Active DataGuard in the mix. Exadata by default uses RAC, so those are gold configurations. And then autonomous is sort of unique. We don't have support right now for Active DataGuard in a hybrid fashion yet, or DataGuard for active from a hybrid fashion, but you can use Golden Gate to go ahead and configure a hybrid DR scenario or high availability. I want to point out that some of these, like Golden Gate, are manual configurations. You have to go outside our control plane to go ahead and configure them. All right, I'm going to give one multi-cloud example. Multi-cloud would be, basically the application is running in another cloud or running on your data center, and the database is running in the Oracle cloud. You want your cake and you want to eat it too. I want the Oracle database. I want to use RAC. I want all the capabilities, all the advantage of running XSCS. But for whatever reason, I want to run my app tier on another solution. Let's say if you want to run Azure, we even have an Azure interconnect to make a very fast connectivity there. From the app tier to the database tier. So we can do all our MAA still and take advantage of it. And I like to have our partner Megaport in there to even have the network redundancy. You can see them in the diagram as well. So this is a gold configuration. So we have it set up. We have it configured. We have our local standbys, and then we have our remote standbys, remote data center associated with that. And now we can go ahead and kind of see where we get the redundancy from the app tier as far as taking advantage of it. With interconnect, we don't get any latency associated with that. It's very, very fast, and you can use Fast Connect as well. Kind of ties in with this. We also have Equinix as one of our partners, so there's a lot of different cloud partners out there that co-locate regions as well. With specifically with Azure, we have this interconnect, so you can take advantage of it. But there's no reason why that pink block couldn't represent your data center as well. One of your data centers, you can have the app tier running there. So the idea at Oracle is we want to give you the flexibility to run what you want to run. For whatever reason, if you want to run the app tier in a different cloud or you want to go ahead and run it on premises, by all means, you can take advantage of it. So we provide all that capability. And the MAA, we're here to help you as well. We're going to be rolling out some collateral tied with this. And with that, I'm going to go ahead. I'm 3 minutes over, so I'm going to go ahead and wrap it up. As it's really late you guys' time, and I want to respect that you guys stuck with me here. I really love it. I know you guys have been asking questions, and I'm already I know a lot of those questions have been answered by Suraj along the way, but I'll leave you with the fact that high availability and disaster recovery is absolutely critical to the business. Maximum availability is a set of blueprints and solutions, best practices, not just the technologies, but the best practices of configuration management. And in our cloud, actually, we've even automated these best practices. for these environments. So it's important that you follow those best practices and look at the blueprints that we've gone ahead and provided so you get the RTO and RPO that you want, that you're striving for. And this can be used for both planned maintenance. In fact, it needs to be planned maintenance as well as unexpected outages. It applies to both. Keep in mind that planned maintenance happens even more routinely. And we have other technologies in here that I haven't even talked about, like fleet patching and provisioning, formerly known as rapid home provisioning, which is also a part of MAA, to go ahead and expand that into fleet patching so you can standardize and use gold imaging to do out-of-place patching. So take a look at this. All FPP is all documented in there. A lot of these features are. So we have a lot of supplements to this as well. We have all our different resources associated with that. You can take a look at them. Just go ahead and search for MAA, but we have them for on-premises, Exadata, and we have them for cloud, a list of resources. And take a look at those new DataGuard best practices we just put up there. They're really easy to navigate. I recommend that over jumping through the different white papers that we have historically. And now I've left absolutely no time for questions and answers, but I will go ahead. For those that want to stick around for a second, I will go ahead and answer them. And I see Suraj has already gone ahead and responded to some. You can certainly get a copy of the presentation for those that ask. I know that's always one of the questions out there. As I see a few questions, I think mostly have been answered, but there are a few. I think I already answered some ZDL features associated with it, as well as the app continuity features. I do see a great one that where the DBMS redef, our online operations, is there considerations to working with Golden Gate? And the answer is yes. I mean, basically the replication, the way it's going to work is going to asynchronously go ahead and replicate there. But you do need to think about it. One of the key challenges with Golden Gate for an application upgrade, in some ways it's better to use EBR for the application upgrade, because what it actually does is when you take the DBMS redefinition, you have an application workload. If you split it between the two of them and you're changing your application, you have to go ahead and do more synchronization between it, right? EBR takes care of that with cross-edition triggers. It's going ahead and propagating data in both directions to keep the data set in sync with each other as the schema might be changing, as you're adding new columns and those type of things that you might be doing with online redef. So depending on what you do with online redef, the answer is it'd be fine with Golden Gate. But certain things like adding columns and changing your schema for an application, or going ahead and swapping out a stored procedure or something like that, would be better done with edition-based redefinition for that reason, to go ahead and kind of combine them together. So we have some recommendations for that to go ahead and work through. And beyond that, I think I've gone ahead and jumped
I've answered most of the questions.
Yep, perfect. So in that case, we will go ahead, and I thank you guys for hanging with me through your evening. I really appreciate it. And the session should be available to others later in PDF format or the recording. Thank you, guys.
Thank you so much, Glenn, for your time and a wonderful session. I must add, Suraj, thank you so much for sticking around and answering the questions and helping us out. So before I close, just a quick look again. We are really, we're looking forward to hear from you. Feedbacks would be really appreciated. And here's a quick look at the upcoming sessions. We've got a really interesting live labs session coming up on Friday. Now, this is all about getting your hands dirty. It's a walkthrough walk through the various live lab scenarios that are present. So we would have Ludovico as well as Suraj on Friday. So hope to see you then. And I will be closing the session now. Thank you so much, everyone.